know Cecile since quite a while. We are working together in the GSEU project, building a geological service of Europe, and she is leading the subtask of building vocabularies of anthropogenic deposits. She is a researcher at the BRGM and just the right person with a background of, I think, also geochemistry and environmental geology to work on that topic. And I'm very happy, Cecile, that you're going to give us now a lecture and a presentation on the anthropogenic deposits and their importance. Maybe I should add that the first thing on thinking of anthropogenic deposits, I can think of this is how important it is now in these times also to not only have a look at landfills or at dikes for coastal protection, but also at the raw materials that are hidden in the tailings that are remnants from the mining. So this is a very good time to have a look at the mapping and of the description of anthropogenic deposits. And again, Cecile is just the right person to give us not only an impression, but a deeper insight. Cecile, please, the audience is yours.
Thank you very much, Christine, for introduction. And so I am very pleased. Thank you for having proposed me to do this lecture. And I'm very
My
pleased
pleasure. Thank you for saying yes.
Yeah, to talk about anthropogenic deposits as a component of urban geology. So I'm not going to speak only of urban geology, but quite a lot, actually. So just I divided my presentation into 5 parts. So first, of course, context, followed by some examples of anthropogenic deposits and associated issues. A slight deeper aspect of anticipating intrinsic pollution of anthropogenic deposits with the work carried out on Nantes Metropole. And some vocabulary aspects, of course, linked to the GSEU project, and some conclusion and perspectives. And before going to the context, just let me tell 2-3 words about BRGM, the French Geological Survey. So it's we are more than 100 people at BRGM, and we address multiple domains. In this frame, we build several reference database for geosciences, but we address also various thematics like geology and subsurface modeling, so in which this lecture takes place, but also risk linked to the ground and subsurface. So we'll see we have some links to that too. All the aspects of mineral resources and responsible supply. So there are some links also with that, with anthropogenic deposits. So groundwater and resource preservation as well, and also the subsurface energy and decarbonation, and of course all the digital technology aspects for geosciences. And so we have several missions like scientific research, but also support to public. Oh, sorry, I forgot to share my screen, I guess.
Yes, we wanted just to remind you on that one. Would be nice if you could share your wonderful slides. Thank you.
I think it's not a problem if I missed the first slide. But then just as I shared them earlier, I forgot that I removed them. So, and so, yeah, I was just so presenting virtual missions. So you see all what I've been presenting and all the topics and all our missions. So I was telling you we had some scientific research missions, but also support to public policy development, some international cooperation, mining safety aspects, but also training. And so just to, let me see. So the summary, I talked about it, but if you want to have it a quick look visually. And so I had also this kind of images of anthropogenic deposits in the urban environment that were kind of an visual introduction as well. So let's move back to my presentation now with the context. And so for me, the context is that subsurface, especially in the urban environment, is the support of cities. And it provides some opportunities, but also some constraints. Opportunities are linked mainly to resources like water, energy, materials like soil, rock, sediments, but also other resources like space, with, for instance, cavities. Subsurface may be at risk, with natural risk like landslides, collapses, earthquakes, other natural one leads to water like floods, and anthropogenic risk like pollution. And so it's important to consider subsurface in spatial planning and to get a good knowledge of urban geology. But there are some gaps. And I have a question. Do you see my mouse on the screen there, or do I need to? Do I see my mouse moving on the screen?
Yes.
Yes.
Yeah.
Yeah. Okay. Great. And one of the gap is the knowledge of anthropogenic deposits. It's a poorly known component of urban geology, actually. So some definition, actually, anthropogenic deposits were created by anthropogenic rather than natural processes, and they consist of displaced or reworked natural rock fragments and sediments, and or non-natural noble or secondary materials like bottom ash, slag, crushed concrete. So it can be various types of materials separately or a combination of them. They are widespread. As shown on these figures on the right, to the right, bottom right. So on the right, you have an extract of the geological map of city of Rennes in France, with just anthropogenic deposits mapped as in this little circle, red circle. But if you look at the description of anthropogenic deposits in boreholes, you see that you have them in much larger areas of the city than what is mapped on the geological map. And this can be explained by the fact that the city is developing above the city also. In this frame of example of the city, developing of the city, the example of Rome and Aachen, so in Italy, Germany, are a good example of this. Here you have a map of, or a model of the thickness of anthropogenic deposits in Rome city center, with until more than 20 meters of deposits in some places, and some deposits are very old. Some are before the 19th century, but Rome is known to be an antique city. In Aachen, Germany, you have here a cut of the geological. Okay. And you see that you have also several meters of anthropogenic deposits, and with a patrimony, like it's kind of it has some geoheritage interest. And actually, there are large volumes of anthropogenic deposits. And the examples from the Netherlands is very interesting. You have million tons of anthropogenic deposits that are used or materials that are used every year to build anthropogenic deposits. And we have lots of natural materials like sand, for instance, but also gravel and crushed rocks. And important part is also non-natural material, like demolition waste, for instance, or asphalt granulates also, and also clean soils. If we look at the characteristics of anthropogenic deposits, they usually show some discontinuities towards the natural geological material. They show also technical and environmental properties different from those of natural deposits and rocks. And actually, there are various types of anthropogenic deposits. Some can be highly heterogeneous, especially when various types of non-natural materials are present. And they show also variations in both lateral and vertical extent frequently. So it can go from a few meters to dozens of meters. So let's move, now that we have this context, let's move to some examples and issues. So as deposits, we have quite lots actually of waste deposits, we must say. Examples here on the top images are deposits made of municipal waste. Sometimes they can be unexpected, and we can find them during redevelopment with all the problems that are caused due to their presence. Sometimes they are really nicely managed and redeveloped. Here, for instance, as a green park. So we can have them above ground to fill former quarries, but sometimes also to fill underground cavities. So another important examples, especially in Europe, is the demolition waste, and those from the Second World War, with various ways of dealing with them, sometimes only spreading them all over the city, but sometimes also building some hills out of the demolition waste, like in Berlin here, with the image of the building of the Teufelsberg, with all the demolition waste of Berlin, and which is now a nice park within the city. But of course, there are not only waste deposits. For instance, in transport infrastructure, we get some road construction materials that can be made out of crushed rocks, for instance. And for landscaping, we also reuse often excavated soils, sediments, or rock fragments. But we may have in between, like in these photos, some industrial waste, for instance. And in the left photo, also some municipal waste below. And all these deposits, of course, you have various types of deposits, but some issues that we find, like resources. We can get some materials from these deposits, sometimes critical raw materials. I was telling about the geoheritage with the patrimonial value of some of these deposits, especially when they have archaeological remains in them. But sometimes we also have some risks linked to these anthropogenic deposits. Risks like land compaction, landslides, and also pollution. And all these issues are especially for pollution, but you may have sanitary issues, but also environmental, economic, and even legal issues. And if we focus more on pollution, So we think more often of pollution linked to human activities, but actually anthropogenic deposits are also maybe also a source of pollutants. And this may be important to consider at various scales. This goes from playgrounds with different exposure possibilities for, especially for the children, when it's a gardening activities are carried out. Then you have the in addition to ingestion, inhalation of soil and material, you also have questions of vegetable ingestion. In terms of planning, you have to anticipate this for desealing and renaturing. And in redevelopment project, you have to anticipate the presence of polluted anthropogenic deposits when you have to excavate it and manage soils, and may need some project adaptation. And if we think of below ground and what the use of groundwater, this may cause problems to the quality of water, especially if it's used for drinking purposes or even for other uses. So this is let me transition to the work we've carried out in Nantes, France, to anticipate pollution linked to anthropogenic deposits. So in the case of Nantes, we have quite lots of anthropogenic deposits that are mapped in the geological map, already included in the geological map. But and in the borehole description, we also have only mention of anthropogenic deposits, with here an example of 4 meter thickness of such deposit. And the questions of the polluted anthropogenic deposits was linked, raised in link with the redevelopment project in the Nantes Island here, with the photo to the right, especially with the southwest part of the island, which is being redeveloped. It's about 90 hectares out of 337 for the whole island. And there are large volumes of excavated materials that are expected, about 100,000 tons per year for about more than 15 years. And we have pollution issues linked to former industrial activities, but also to anthropogenic deposits. And we'll see, for instance, we had some demolition waste from the Second World War that were spread over the city, and some industrial activities that were impacted by the war as well, and also industrial activities that conducted to pollution. And the pollution linked to anthropogenic deposits themselves are linked mainly to the reuse of industrial waste as a layer to raise the topography of the island. And so in this redevelopment project, there is a need to anticipate the quality of excavated material. This is to optimize the management cost of this material, but also to limit the environmental impacts. And one target is also to adapt the project, redevelopment project. And by better management of these excavated materials, the developer expects to save almost €1 million per year, which is important. And in this frame, so they asked for help, and we did some methodological development to build a typology of anthropogenic deposits according to their intrinsic pollution potential and integrate this typology in a 3D geological model. So how did we proceed? Actually, we collected and exploited borehole descriptions. So actually on the whole island, we collected more than 2,000 boreholes. This interpreted them in more than 7,000 lithological layers. We also had more than 3,000 samples that were analyzed, and more than 100 analyzed parameters. So a big database. And so the work was conducted as to transform these heterogeneous descriptions, borehole descriptions, into interpreted descriptions, integrated the typology of material that we developed, and to compile it into a stratigraphic pile to build the model, geological model. So the exploitation of borehole descriptions conducted us to work on the terms used in the borehole descriptions as indicators of intrinsic pollution potential. So for instance, bottom ash, slag, asphalt, tar, coal, natural materials conducted us to classify them as high pollution with a high pollution potential, and some specific colors also helped us to classify the borehole description or the layer interpretation into pollution potential. And for the other type of materials were considered to have a medium pollution potential, like concrete, masonry, glass, brick, and so on, that are more linked to demolition waste and that are known to have higher content of PCBs, so polychlorobiphenols. And this actually was validated, this approach, thanks to the analytical databases that we had. And we see that so the highest ratio of geochemical anomaly was observed in the materials classified with the highest pollution potential. So like these geochemical parameters like lead, zinc, or copper, and some were like barium and nickel were more linked to natural materials and didn't show any anomaly within the materials classified with higher pollution potentials. Apart from the borehole descriptions and analysis, we also collected and exploited other historical data like maps and photos. And this allowed us, for instance, to map the filling deposits. So the Nantes Island was formerly a set of smaller islands that were progressively filled to build the whole current island, and with dates. So the red deposits being younger than the green ones. There was also filling and rising deposits. So this is another neighborhoods on which we worked, but the image is nicer, and we had here all deposits of dredge sediments. So the sand that you saw on the figures above earlier, that were just spread all over this area to raise the topography, and because these were flooded plains before they were developed. And this allowed us to build a 3D geological model, and to extract some 2D visualization that the developer is using. So the model was developed with the GDM tool, and we have the basement rocks, the alluvial deposits, and then the anthropogenic deposits with their level of intrinsic potential. We also extract a map of thickness, and so we can have until 8 meters of anthropogenic deposits on the islands. And you see that most of the island is concerned by anthropogenic deposits, but not the whole island, which should connect us to refine the geological map. And if we look at 1 meter depth, then you have so lots of red anthropogenic deposits, so those with the highest pollution potential, which are very present, and more yellow ones with less, which are the dredge sediments from the Loire River, which is around. And at 3 meter depth, we only observe or mostly observe these dredge sediments that were used to raise the topography of the island. But here, still some red or orange ones with high and medium pollution potential intrinsically, which correspond mostly to a former landfill. And actually, if we look at the volume of these deposits, anthropogenic deposits, according to the class of intrinsic pollution potential, we see that in the 4 first meters under the topography, you have about 20% of intrinsically highly potentially contaminated anthropogenic deposits, 13% with medium pollution potential, and about half with low pollution potential, and only 10% of natural alluvial deposits. So this methodology was applied in other neighborhoods successfully, even if we had much less boreholes, and with, of course, higher uncertainty linked to the less amount of boreholes, and with other types of anthropogenic deposits that were developed, like here the micaschistous deposits that were used here, that come from that are natural materials, but coming from the building of the ring road of the city, and which are in our area often rich in arsenic. And so the work in progress now, following this, is to reduce the geological model uncertainties linked to anthropogenic deposits with the PhD work of Simon Gauthier, which is in progress, and with the idea of using geophysics to have more continuous information and to integrate these geophysical results in the geostatistic analysis or modeling, and to also use artificial intelligence to improve the modeling processing. And the idea is to have a better knowledge of the various types of anthropogenic deposits according to the intrinsic pollution potential, but also if we manage to also check other characteristics like the compaction, and the infiltration capacity. And we also have, we expect to have knowledge on water content and clay as well. So this work is being part of the French research project on the sealing, which is called Permepolis, which I'm leading as well. So if we, so let's move now to the last part of the fourth part of the presentation, dealing with vocabulary. And as a transition, so when we integrate anthropogenic deposits in geological models, we can have various objectives possible for these models. We can have mono or multipurpose models like hydrogeological engineering with the excavation of soils and subsoils, geoheritage questions, critical raw materials or pollution. And the objectives are linked also to the issues. It is more linked to resource protection or exploitation of some resource, or to the issues linked to risk with anticipating or management of this risk. And here the photo shows an example of the geotop model in the Netherlands, where anthropogenic deposits are these gray deposits, so undifferentiated deposits integrated here for hydrogeological and engineering purposes. And as I expect to have shown you or convinced you with the example of pollution in Nantes, it's important to have a better description of anthropogenic deposits. And in this frame, we need to have a common vocabulary to allow their integration in geological models, but with an applied perspectives. And actually, as for the modeling of anthropogenic deposits, the issues are mainly at local scale. And let me now present you the work on anthropogenic deposit vocabulary that we are doing together with Jeroen Schokker, Christine, Asch, Ursula Stepien, Jan Malstra, Paul Heckman, within the GSEU project, which is Geological Service for Europe, as part of a subtask of work package 6 on geological framework for the digital European Geological Information System. So we have a work dedicated on vocabularies. So our objectives is to provide terms and a classification for use in 2D and 3D modeling, so for geometry, but also for characteristics of anthropogenic deposits. And so we chose a lithology-based approach. And in this frame, we developed a data model, worked on a set of vocabulary, and are using use cases to test the vocabulary. So until now, we've developed the conceptual data model. So it's everything that's not in gray. So we have anthropogenic deposits are considered as anthropogenic units as a geological unit themselves, with anthropogenic materials characterized by their nature, but with optional properties like grain, color, or odor. We didn't have time to address this in GSEU, but still important to take into account. And we're also working on optional properties like the purpose of the deposit, the origin of the materials, the process of deposit itself, the environment of the deposits, and the shape of morphology of the deposit. And also in anthropogenic deposits, we may have natural materials as well. And in this frame, we expect to use the lithology rock type materials developed in another subtask of work package 6. So if we move, for example, to an example of vocabulary, for instance, for anthropogenic materials, the descriptions are based on material science classification. And so we use them and add another category to complete with the vocabulary that is not present in the other classes. If we move to your use cases, so some illustrations of the use cases. So former landfill here in Nantes, the geoheritage. So in Aachen, so the pollution, more landscaping deposits in the case of Nantes, some waste material from a chemical industry, and here some examples of mining residues which are important as potential critical raw material resource at the moment. So here are the sites corresponding to the images, but what is interesting here is to see the environment. Some of these deposits, some are in urban environments, but some are also in rural or in mining or even in coastal environment, and with issues linked to pollution and groundwater quality, but also to climate change with sea level rise, for instance, in the case of the former landfill in Nantes. Again, pollution in Nantes, but also water infiltration, geotechnical stability, archaeological remains, all the questions of cultural heritage, also some mudslides, erosion, geotechnical instabilities, human health as well, and so and flooding. So very many issues linked to these deposits. So that's all for now, and let me now conclude. So anthropogenic deposits, so as I said before, are widespread but poorly known. There are geological units, but with anthropogenic processes to build them. They face many issues, and especially in the urban environment, you have economic, environmental, sanitary, and legal issues. And in rural and mining areas, you have also these issues. Various characteristics of anthropogenic deposits are useful to know to manage them as resource or the risk associated. And in this frame, the GSEU project is filling a gap by providing vocabulary to describe anthropogenic deposits, including the materials and some attributes. And the vocabulary should be ready by the end of 2026 and available in 2027. And as perspectives, I would say that the subsurface offers geosystem surfaces that it's important to consider in spatial planning. So not only urban planning, but spatial planning. And in this frame, a good knowledge of urban geology or subsurface geology is needed, and thus of anthropogenic deposits. And thus, therefore, the research on vocabulary, but also on modeling and the integration of anthropogenic deposits as part of surface geology is important to continue and to continue also to integrate them also in spatial planning. And this should be done in link with GMMEG and EuroGeoSurveys expert groups of the EuroGeoSurvey. And so thanks for your attention, and I'm ready for questions now.
Thank you very much, Cecile. This was really excellent and a deep insight in not only what the research of yourself and BAGM is doing, but also what we are doing within our task on anthropogenic deposits in the GSEU project. And you also wonderfully and rightly so mentioned that there is a very deep connection between UGEC and our geological mapping and modeling expert group. So thank you very much. I have followed the chat, and there are two remarks and questions, but I would like first to ask the audience for your remarks and questions just now. Okay, well, I think I first start with, which I have forgotten in the beginning, being excited that Cecile is with us and starting to give the talk. My name is Christine Asch. I'm from the Federal Institute for Geosciences and Natural Resources in Germany, the BGR, and I am happy and have the pleasure to chair the GMMEG group. So I should have done this in the beginning, but it was much more important to introduce Cecile. So, and now you had a little time to think about if there are any questions. I can't see any thumbs up, if I can see anything, or hands. So let's start with Annika Åberg from GTK in Finland. Her question is, just out of curiosity, what is the thickest anthropogenic deposit that you have encountered? And do you know drilling campaigns that have been made in order to study the volume of the anthropogenetic material? That was the first question.
So, in my experience, I think the deepest was 12 meters thickness of anthropogenic deposits. And so, yes, we have some drilling campaigns to study the volume. This is especially the case, or to study not only the volume but also the nature of materials. This is the case, for instance, in landfill deposits.
Mm.
So I've been working a lot in about landfill deposits. So I think some would be even more deeper, but the one I really study.
Yeah, I would also think that the deepest ones are the ones from landfills. The municipal landfills, they are really also landscaping and changing the landscape. And I can also think that the tailings are enormous. Think of the big Kali, the big salt tailings.
But as part of drilling, I would say that, and so in the Aberets former mine, we have, I think it's the highest topographic level of the area is linked to the mine tailing.
Yeah.
And I was thinking also another very thick deposits linked to former quarries that were filled with all kinds of materials that we have a bit everywhere. And we have holes until 50 meters is very frequent. And the deepest quarry we have here around Nantes at the moment, which are being filled at is 120 meters deep.
Yeah.
So we can have so the landfill is small, quite small size of deposits compared to mine tailings or former quarries.
So Annika, does this answer your question? Are you still with us? Maybe some problems with the techniques. I would suggest come to the next question. There are several ones. This is from Fernandino Gerson from Brazil. And he is asking, hi, Dr. Lajan. thank you for your excellent presentation. I found it curious that in your 2018 paper, using borehole descriptions, plastics apparently weren't considered in the pollution potential analysis. I am sure plastics came out in the analysis. Other, more inert materials, such as glass, were included and plastics weren't. Were there any reasons for not including them? Thank you. This is a question from Fernandino Gerson.
Yeah. Plastics, let me think. So plastics, we have some plastic description in boreholes. So we have included plastics in our vocabulary in the GSEU project.
We did.
So that's for sure. And in the 2018 paper, actually, plastics were not considered. Were part of. So in the category with glass was more linked to demolition material or all kind of this material. Sure, glass is more inert, but plastics were not considered to have to be at geochemical risk as such. But of course, in landfill deposits, we have very many plastics. In demolition waste, we have also we may have pieces of plastics, of course. So plastics are quite frequent, especially in recent deposits. We won't have them in older deposits because plastics is a quite recent material, nevertheless. So would I consider it differently now? Which would be the questions. So I believe it's an indicator of anthropogenic action. That's for sure, of anthropogenic influence. So it's important to describe it. But as a pollution source, we were thinking more at geochemical pollutants rather than at plastic, which is now considered as a pollutant as such. But with say not the same health issues as the presence of lead or PFAS or some organic contaminants that we can easily that can have impacts, more quicker impacts, let's say. So this is an open debate about plastics, how to consider plastics.
Yeah, thank you, and thank you also to Fernandino Gerson to raise this topic. I'm just looking for the next one. Oh, this next one is from Teddy Rees from BGS. And he is asking, he first says, thank you, Dr. Lejeune. I have a question regarding the deposit classification. You mentioned that the old geological maps show limited anthropogenic deposits. I can confirm that. Presumably, they were originally mapped using a different identification. Have you been able to reclassify these records with the new system? Interesting question, good question. I first let you answer it, Cecile. And I see that Teddy is still with us, so we can discuss. Cecile, please.
So actually, we unfortunately didn't have the opportunity yet to modify or to adjust the geological maps with this new knowledge on anthropogenic deposits. But actually, I hope the PhD study by Simon Gauthier will help to try that, at least in Nantes. And I hope we can then do that in other places. But still, we are at the very beginning of this development, I would say.
If you allow me to add,
Yes, sure.
look from the geological side and from the mapping that we see and do, for example, in Germany, we do map anthropogenic deposits, but classified according to very general terms. A couple of years ago, also in Germany, a classification of anthropogenic deposits was set up in order to be more thoroughly. We have, I think, around 30 different classifications, which also goes through into the anthropogenic deposit vocabulary. Cecile is guiding us for the GSEU project. But in the former times, when the geological mapping went on, Teddy, maybe you also know this, the anthropogenic deposits were not the focus of the geologists. Only now they become more frequent and they become more interesting. So going into the archives will probably not reveal not too much of extra information apart from what we already have in our GIS database or maps. Would you like to comment on this or answer this, Teddy? I see you are still with us. Maybe not, I don't know. I hope everybody is free to answer some. I see some. So Teddy is happy with the answer so far.
No microphone.
Very good. The next one is somebody. Oh no, she says, that's great. Thank you both. Yes, we have similar challenges here, so it's very interesting to see how this carry forward. This is what Teddy answers. And Fernandino Gerson says, thank you for your response. I'm open for future discussions on how to include plastics in the type analysis. And Teddy says, apologies, no microphone. Perhaps the same is the case for Fernandino Gerson. Then, of course, you can't say anything. It's great that you are with us, nevertheless. So now I'm coming to Florina Mihalea Tulucha. Hopefully I pronounce this correctly. She says, I hope you don't mind me sharing this, but I would like to draw your attention to call for papers for a special issue on the topic urban surveys for sustainable cities. And you will see the link to that call for papers in our chat. And no, we don't mind. It's a very good idea. Thank you for sharing this. Right. So I'm looking into the chat. Thank you, by the way, for using the chat. This is very good if you have no microphone, for example. Are there any questions or additional remarks on what Cecile has given in her talk just now? Well, then I don't see any waving hands. I would like first to say thank you to everybody to attend this, and especially thank Cecile for her really excellent, very interesting talk, also including our work in GSEU and also the link of the GMMEG with that topic.